Hey, hi. So, my name is Rahul, and this is Vishal, and we're going to have a very interesting talk. This is actually a research which we did a while back, which is responsibly disclosed to all the companies which we will be mentioning about. Before I go into the research, right, I just want to explain the reason and the way we reached this research in the first place, right? This all came back from a project which we did a year back. The whole idea of that project, and we call it Bevigil, by the way. I'll just give you a introduction of that as well. Well, the idea was that on your phone, right, on your phone, you have an Android or an iOS, you would have almost 20, 30 mobile apps installed, and each of these apps will have some amount of access to your data, whether it could be SMS, could be gallery, it could be your contacts or whatnot. You do not know at this point of time which of these apps are secure, but you have it anyways. So our thought process was that, well, can we rate, can we give the power to the community and the people to actually know the security of any app in the world and free of cost, right? So this gave us the idea of the project Bevigil. Bevigil is actually the reason why we have this data set. I just want to quickly show you what it does. It is actually a symbol search engine. It's a free search engine. You can go put the name of any app in the world. It'll give you the security score and a security report. I'll show you and I'll tell you why this is important before I give the talk, because this will set the context. So it's basically a search engine. You put, anyone has the name of an app. Any app, just shout out the name if you have on your phone or on top of your memory. What is it?
Spotify,
right? I hope the spelling is correct. Well, yeah, that's it. Well, it'll give you all the apps that has Spotify, the word Spotify in it, first of all, and it'll also give you the security score of all of them. Well, in this case, we have I think close to 69 apps, by the way, but obviously the top one is the main Spotify app. The rest of them would be clones or ripoffs, etc., etc. But then you can see that there's a security score associated. Well, then you can actually go check the report. Well, the report will give you pretty much, what we do is we go into in-depth analysis of the app. And again, it's free, by the way. And it'll give you all the security issues associated with it. This way, a consumer would know what is on his or her phone, right? And then so much more information, right? And you can actually go very specifically check. In case of Spotify, I know you might not be able to see. Let me just screen. These are the high-level security issues. For instance, they have something called app login, right? And there is a chance that the SDK key of app login is hard-coded in the app. We'll come to know about it. But the thing is that once we launched this, consumers, so people started, sending apps requests to test, right? And as of today, we have 1 million apps in the world scanned. So a data from 1 million apps, basically security report of 1 million apps is available, which is the base of this research. Now, what we found, can we go back to, so what we found from this slide, right? Yeah, present. Yeah. So what we found, looking at all these 1 million apps in the world, is a huge number of these apps have crazy security issues. When I say crazy security issues, there were almost 10,000 apps who has hard-coded AWS API keys inside the app. That means an attacker can, you would know an API key of AWS is like the password of AWS server. An attacker who has access to the API key can literally get full access to the AWS infrastructure. Many of them had, the Firebase key. Some of them had Firebase URLs which had by default write permissions into the database. So if you look at the whole statistics, we found, a crazy number of apps, like lakhs of 100K, 200K apps with some of these high-level issues. Now, many of them, what you see on this sheet, are hard-coded API keys, right? Hard-coded API keys or a hard-coded password to a critical infrastructure. What is the infrastructure? It could be Zendesk, by the way, where all the support tickets are stored. Well, that API key is actually inside the app, right? Like I just said. So the thing is that, we have almost 200 plus signatures of API keys, which we are specifically looking for in these apps. Now, after finding these keys, one of the interesting things was, how many of these API keys can actually be exploited to get some deeper insights or deeper access, right? So this research very specifically focused on one key, which is Twitter. We have published multiple reports on how attackers can exploit other keys as well, but this is very specific to Twitter keys. And yeah, so I think, again, like I'm like the manager who just does all the talk. Vishal is the guy who does the actual work. So, I will hand it over to him. But the research very specifically covers what did we find in Twitter API key, because we found 3,000 companies leaking their Twitter API keys inside the app. Now, if you get access to a Twitter API key, what could you do with it, right? I mean, not all cases you could exploit it, by the way, but we did some research and we were able to find out with certain scenarios which will actually give you access to the entire corporate Twitter account of the company. Everything you're going to talk, we disclosed to Twitter, some of them to the individual companies as well. So over to you, Vishal.
Okay. So thank you, Rahul. So basically today we are going to talk about how we hacked the unicorn companies. So basically we compromised the Twitter accounts of many unicorn companies through doing our research. So first we'll be talking, there are the three agendas for this. So first we're gonna be, what did we find, where did we find, and in the second part we'll be covering like what could be the impact or what could be the impact or severity of these keys leaking or the keys which we have found. And the following forward, we will go to the remediation part, like how developer can prevent these mistakes, what could be the mitigation or the remediation of those keys. So we will start from the key source and the key finding in the source. So we have built our own security search engine. So as you say, the BVigil itself. So what are the steps we took to show the alert at the BVigil? So in the first step, we used to collect the mobile apps, and in the second steps, we decompile the apps, and following, we build our own regexes. We grab the regexes from the different sources, used to test the regexes, and the third, we search on a large data set. Now, how do we collect the mobile apps? So there, when you use the BVigil itself, you will find there are the two ways to get the mobile apps. So one can locally submit the data, locally submit the package ID through the BVigil itself, and the second, user can simply pass the package ID or the Google Play Store URL at the BVigil, and it will index those apps at the BVigil. Moving forward, so how do we decompile apps? What are the tools we can use? So one can also use the locally to decompile these apps through different open source tools. So there are many open source tools available right now on the internet. So you can use the APK tool or JDGUI. But in the case of BVigil itself, we use the JADX tools, which basically decompiles the package ID, and we start the static analysis of those code. Third, the toughest part of all. So if we decompile the app, But so if one is trying to find or do the analysis of that code, so how he could find these secrets or any keys leaking at the BVGL? So for that he has to write the regexes for that, or he can use the grep command through he or she could find the any API keys or the secrets or the keys which are leaking at the code. So we have built our own. So basically we have many more, like we have 300 plus regexes from the different service. It could be the ad network or the social media or the payment processor, or it could be CRM. So we do have the regexes from different services, which basically we build our own regexes, and we also test some regexes which are publicly available, and we test it and then we deploy at the BVGL end. Okay, so one has the BVGL has also the features where you can enable the regex search, and you can simply search for the AWS keys or the any keys like Stripe keys it could be, or it could be the Razorpay keys or HubSpot API keys. So you can simply pass the regexes, or you can simply search the keyword which you wanted to, and it will present all the keys which are leaking in the apps or the companies which are leaking those keys or those secrets or those tokens itself. And the moving forward, so why we started doing the analysis for the Twitter? So basically we got so many hits at the BVGL itself, as you can see in the number itself. So we got the consumer key 89k plus, and the consumer secret itself 27k plus. But we had no idea like what to do with these keys, like how we can exploit these keys. Like, so we started searching at the internet for the any resources which has like exploitation of those keys. If there is any exploitation, if there is any resources which can help us to exploit these keys. So we at that moment we had no idea. So and also we check for the reports, like as many of us, like the security researchers do a bug bounty hunting. So in that case I checked for the reports if there is any bug bounty hunting reports for the Twitter itself. There were no any reports for the Twitter things. Like I saw some of the reports which were saying only the keys are leaking, but they don't know how to exploit these keys. So then we pick up those Twitter keys, we hits whatever the hits we got, and we started our research on doing how we can exploit this keys. So for that, the threat parts. So we have the findings, we have the keys. Now what could be the threat or the impact of those keys? How one could leverage those keys or those findings? So for that we started reading the API documentation or the whatever the resources that could be available for the Twitter. So for going through the API documentation of the Twitter, we came to know there is two types of authentication Twitter is using for the keys. So one is the app-based authentication. So in the case of app-based authentication itself, in the case of one is the app-based authentication, and the second one is user-based authentication. So in the case of app-based authentication, what we can do, so in that developer, it has basically read-only access for the developer who can search for the public information, like we can search for the tweets or whatever the things are going on, trendings on the Twitter. So these are the functionalities which gives the Twitter for the app-based authentication. And for the app-based authentication itself, there are only two keys requirement. So one is the consumer key and the other one is the consumer secret key. So we started going through the user-based authentication. So for the user-based authentication, we need 4 credentials. So that is one is consumer key, second one is consumer secret, third one is access token, and fourth one is access token secret. So for that, what could be done with the user-based authentication? So basically it correlates with the user session token. So in that case, one could simply do all the critical functionalities what Twitter gives us. So basically that could be reading the tweets, basically that could be the reading the DMs, retweeting the tweets, gaining access to the followers, like one can follow himself or herself as well. One can simply tweet anything from that account. So basically these are the things which can be done with the user-based authentication. So what are the naming convention for the keys? So some developers also use the different names or for the same thing. So basically that could be the API key. When you decompile the apps, you will find these are the keys. Like API key is the API key, consumer key, customer key, or the consumer API key, or the auth consumer key. These are the same thing. Like only the name is different. So what developer does? They basically put the different name for the different keys. We can also look for the secret as well. So there are like secret as well, the app key secret or API key secret and the consumer secret. These are the name of the secret. So we can also check for the tokens as well. So in the case of token as well, we know there are the access token or the token. These are the same names. And the for secret as well, we can have the access token secret or the token secret. So these are the names which are for the keys itself. So basically why I put the don't complicate the API keys. What the vendors or developer do a mistake. So they basically put the different variable name and with the different key. So in this case, as you can see, here it has written the Twitter consumer key. But the token which are leaking, it's an access token. So in that case, the developer might think that it has like limited score for the Twitter consumer key. But as it's leaking the Twitter consumers, Twitter access token, so in that case, we could compromise their Twitter account. So we could play with each and every functionality of the Twitter, whatever the Twitter gives us, and that's it. So moving forward, what are the impact of leaking 4 keys? So impact of leaking 4 keys are like we can have the user-based authentication. So in that case, we can read DMs, retweet, like or delete any tweets. We can remove the followers or follow any account, get account settings or the change display picture or whatever the features do a Twitter gives us. So these are the apps. Like first we got these many hits, 89k and 27k for the consumer key and the consumer secret, and then we filter out like how many keys are valid from these which are the leaking at the app itself or the company itself. So we did the automation for that, and we found that there were apps which are leaking only the both keys were more than 4k. So from that apps itself, we started digging further and we check that how many apps are leaking valid key. So there in that case might be those keys are leaking the dummy credential, or that might has been revoked, or that might has been false positive. So we removed all those, and there were the apps or the companies which were leaking more than 3k plus keys itself. So after filtering out all those, we checked also for the 4 keys, like 4 auth credential, which like the companies which are leaking the all 4 keys, and we found that there were 230 apps or the companies which were leaking all those 4 credentials, which could be used for the user-based authentication. That means we can hijack or we can compromise their Twitter handle for 230 apps or 230 companies. So what about the remaining apps? So what could be the these are the apps, like 230 apps were leaking the 4 keys. In that case, we were able to compromise their whole Twitter account. So what about the remaining apps which were leaking only 2 keys? So in the case of 2 keys, like as I mentioned, then in the case of 2 keys, only what the developer can do, developer has the read-only access permission to the public information. like the search tweets or anything. Apart from that, what he can do, like basically here it comes the Twitter webhooks in the picture. So what is the Twitter webhooks? So basically Twitter webhooks is the things where we can deploy where we can create the Twitter webhooks and we can deploy in the app itself, in the Twitter webhook app. So after getting the deploying the apps in the apps, what it does, basically when a subscribed user do any engagement, it basically sends the JSON event in the live format. So when a subscribed user interacts, like do a tweet or do a delete a tweet or search for any or read or simply sends a direct message to any guy or anyone, then in that case it basically fetch out the events. So that's the events, or it basically sends the JSON payload in the form of the events to the Twitter webhook app. So these are the Twitter webhooks. So for creating the Twitter webhooks, we need a 4 keys, like all those keys: consumer key, consumer secret, access token, and access secret. But to fetch out the Twitter webhook URL, we just need only 2 keys, and we can send a request to the server, and it will send out all those webhook URLs which has been deployed at the app itself. So for that we just need a consumer key and the consumer secret. For that the apps must be using the API, like premium or enterprise Twitter API. So we checked for those also, and we found that there were so many companies which were using the Twitter premium API services, and they were paying $149 per month to the Twitter for that thing. Now here comes the exploit part. How you get the issues of the apps which you are using in your phone. So you can simply go to the bvisual, index that app, and you can have the report of that app. So in that case, you will see all those findings, like whatever the permissions the app is using, what could be the permissions, what could be the dangerous permission the app is taking from your phone, like asking from your phone, what are the third-party libraries, what are the assets that app is using, what are the strings, or what are the hard-coded credentials or API keys or API tokens that is leaking in that code base, and what are the assets, like assets in the case of IPs or hostname or the URLs. It could be anything. It could be the Firebase DB itself, which you can check on your browser whether that Firebase DB is misconfigured or not. So all these things, you will get the information of all these things at the visual end. So for that, when you search any keys, when you search any apps at the visual, it will show the result. And how we got, so basically you'll see the string part where you can find all those keys leaking at the itself. So there you can see all the Twitter keys. Now these are the exploitation which we did. We also compromised some of the verified account on the Twitter itself, where at the top we read the direct messages, DMs of the different companies, and we hacked. These are the companies. There are some companies which have so many followers and they are very active on the Twitter itself. And what we were able to do, we were able to delete or tweet or retweet or remove any followers from their account. So we had everything in the case of the Twitter, like whatever the Twitter offers the functionality for to the user, we have everything. We compromised all those apps. Now, so as you see the Twitter regexes, so we use the Twitter keyword basically as a variable number to find the Twitter keys leaking at the bvisual itself. But there are so many companies which we notice later while reporting to the while disclosing the issues to the Twitter itself or the company itself. We found some of the companies which were leaking the Twitter keys in the different variable number, as you can see, the consumer key, the keys is looking at the different variable like consumer key and the consumer secret. So in that case, the regexes won't find out. So why we didn't use that regexes for finding out such case? Because we are having different false positives. Suppose in the case there were so many apps which were looking only, which were having the consumer key and some string, or they were no any string. So in that case, we were having different false positive. That's why we removed that part and we put the Twitter keyword itself to find out all those keys. So these are not the 230 apps which are leaking the all 4 keys, there are not only the 3K apps which are leaking the Twitter keys and we were able to compromise that. There are many more apps which might be leaking the keys at the TW keyword or any other keyword or any other variable name they might be using in that case. Now here it comes to the remediation part. How we can mitigate or how we can remediate these things, or how developer can basically stop making these mistakes. So first we'll talk about where the problem lies. So basically they are the proper security security pipelines. So whenever the developer puts a code into the production, there is no proper security pipeline. So that should be like, while pushing the code in the production, it should be sent to the security team for the proper source code review, or he or she can use the open source tools as well for the security testing, like if any keys or any sort of a sample, any sort of tokens which he or she has hard coded in the code itself. And there is in the other step, so there is the lack of awareness as well. So as you see, we checked at the internet itself, there was no exploitation of the Twitter keys. So developer don't know what could be the things which can be played with the Twitter API keys if he or she is leaking those keys. So in that case, the developer should be made aware of those keys. And the third is budgeting parts. So nowadays lot of company basically invest money for their web app, like securing their web app. But in the case of Android app, they don't do a proper budgeting, or they don't do a proper security testing, or they don't set up a security team for testing all those mobile apps. So how we can defend against these attacks? So there is the first is the source code review. So one has to do a proper source code review. One has to check for if there is any keys or sample tokens or any APIs or anything like any secrets which are being leaked at the code itself. So these are the things which can be done. Which should be done while doing the source code review. Or there are many more tools which are available. Nowadays there are extension available at itself. So that can be done. So also the GitHub has recently introduced this feature, like whatever, if any developer is pushing any code at the GitHub. So what basically the GitHub does, they actually find out those keys and send out the alert to the developer. Second is the hiding keys. Instead of hard coding the code instead of hard coding the credential or the tokens in the code itself, what we can do, we can create an environment variable and we can put that tokens locally. In that case, whenever you are going to push, make sure you don't put the environment file at the code itself, like at the repo itself. Third one is rotating the API keys. So the API keys should be rotated in every 6 months. Like if anyone has compromised your API key, in that case he might not get used. He could not be used after the 6 months or after the 2 months or after some period of time. So in that case, you have to rotate the API.
One of the things we saw is that, after we report these keys to these companies, they actually removed these keys from the app. Removed it from being hard-coded in the app. But they never rotated the key, by the way. Well, the reason they never rotated is because there's other backend code which is using these keys. And if they rotated the whole, the system might collapse. And this especially not with Twitter, by the way. We saw a lot more with AWS keys where, well, they all fixed it in the code, but never rotated the key, which means you can just go back and find an older version of the app from somewhere on the internet, which many ransomware groups actually does, by the way. And then, well, you can then still find the key, and exploit it.
Yeah. So in this case, one should have remove and revoke the keys, not only the remove the keys. So we, as Rahul mentioned, we sent a multiple reports to the different company, and in that case, basically they remove the keys and they basically release the new version of the apps which get indexed at the B widget itself. But the attacker which has compromised that keys can still use that keys like in the absence of developer. And it's like you have basically changed the key from one position to the different position, but you didn't change your lock. So just like that. So in that case, one has to basically remove and revoke the keys at the same time. Not only the removal key will solve the problem. Third is the cyclic process. It should be the cyclic process, not a one-time process. Like the one time you did the source code review and then you hide that keys and rotate that key. So it's whenever you are going to push any code at any platform, then it should be followed in a cyclic way. So you have to go through the source code review, then the hiding keys, then the rotating keys. So that's all.
All right, thank you. We have time for questions?
Okay. So
unfortunately, we don't have time for questions because it's time for lunch.
Yeah.
But may I know who asked the question? Just a raise of hand. The first one, is there any option to upload the APK? May I know who answered the question?
There is an option.
So, I can show you.
So there's an option.
Okay.
Yeah, there is an option.
There is an option.
Yeah. So for the person who asked the question, actually you can head to the back. We have a small prize for you. So let's head to the back after this. Then maybe we just have one more question. So user uploaded APK submissions collected and stored by CloudSec.
APK
If so, how long?
Apps, we don't store the apps. We only store the reports. Apps, the binary, we do not store.
So basically apps are the package ID get from the user itself, and then we store the
question
reports.
is whether we store the APKs, which we don't.
No, we don't.
We only store the reports.
Alright, so sorry, we're already out of time. So actually, for those who still want to ask them these questions, you can head to the back and approach them during lunch, and they'll be more than happy to answer your questions.
Okay, well, sorry. We have this. Any other questions that interest you, though? We can maybe spare one more questions because there are some pretty good, compelling questions coming up.
All right, sure.
But maybe Rahul, if there's any other questions that
does CloudSec only perform static analysis of the app packages? Is it dynamic analysis? Well, the community version. This is a community version, by the way, and the primary objective is so that it's meant for consumers, so that they should know what is installed on their phone, right? That version at this point of time is very restricted to static. The enterprise version, which I'm, because there's a community stage, I'm not going to sell the company now, which has all those things. Because if you want to do a dynamic analysis, we need the permission of the company. So we do not provide that in the community version.
So it's just static?
Yeah, static. So the community version is static. Yeah.
All right. Are there any other plans to include other app stores such as F-Droid?
Oh, yeah. Yes. Well, we do, if you're putting a package ID, we do look at third-party app stores also to find that app. But we first see if Play Store has it or not.
Or if any third-party apps has been tampered, so we do find the malware itself.
Yeah.
At the beach.
Yeah.
All right. Maybe just one last one.
Yeah.
So how is the security scoring done? So how reliable and accurate is it?
It's based on CWE, by the way. The CWE rating. It's not our standard. It's a public standard which we use to do the rating. We also look at we also look at the exploitability of some of those things. And if you look at on the top of the report, we would have given a percentage saying that, well, this is the percentage this particular incident affects the security of the app. So we do public standards first of all.
So CVSS.
Yeah.
Okay. All right. Since there's just one last one, then okay, fine. How do CloudSec analyze the clone apps accurately if it is using techniques such as obfuscation and encryption?
Oh, well, see, if the apps are obfuscated, it's very difficult, by the way, so we don't at this point of time have a mechanism. Yeah.
All right. Thank you, everyone, for such the wonderful and interesting questions. So we can actually break for lunch now. We'll resume at 2 p.m. So for paid registrants, the lunch is at the back. For the non-paid registrants, can head over to Bugis Junction to find something. So a round of applause for our speakers.